Okay, so let's move on then and talk about how we can find if numbers are perfect squares that aren't just the easy numbers, the ones between 1 and 100 that we've discussed. So let's just say I want to know about the number 144. Now I know a lot of people might say, well, 12 times 12 is 144, so it has to be a perfect square. And you'd be right, that's correct, okay? But if we don't know for sure that this is a perfect square or not, what we're going to use is a factor tree, okay? And we're going to see if we can group all of the prime factors into two equal groups. If we can do that, we know that a number is a perfect square. So let's just have a look here at some vocabulary, okay? If I'm looking for the word prime factors, well, a prime number is a number that only one in itself can be divided into or divisible by. So basically, we're looking for numbers like 2, 3, 5, 7, okay, 11, 13, all those 17 are prime numbers, okay, and we probably won't need to go much higher than that. So if you can't divide anything other than 1 and the number itself into a number, that number is a prime number. Okay, so let me show you what I mean. If I start by 144, I've got my little factor tree here, and what we're looking for is just some numbers that I can simply divide into that, okay? Now I'm going to take the number 144 and break it down into all of its prime factors. So I'm just going to start by dividing 144 by something I know that divides into it. I know that 12 divides into 144. Okay, I'm going to keep breaking down each of these factors until they become prime numbers. So 12 can be divided by a 2, and 2 times 6 is 12, so the number that belongs on the factor tree beside that is 6. The other 12 is broken down into 2 and 6. Then each of those 6's can be broken down into a 2 and a 3. And the other 6 here, obviously, a 2 and a 3. So you can see that I've got some numbers circled in red here. And the reason I've circled those in red is because those are the prime factors of 144. So basically, if I took each of those and multiplied them together, I would get 144. 2 times 2 times 2 times 3 times 2 times 2 equals 144, and those are its prime factors. If I can take those prime factors and put them into two groups that are the exact same, I know that the original number is a perfect square. My second 2, the same group, and my 3 in the same group. That's all my first group. Then I've got a 2 left over into the second group, another 2, and my last 3. You can see there that I've used all of my prime factors. They're all used up, so I'm just going to cross them out. I know that I've used them all in my two groups, and 2 times 2 times 3 is the same as 2 times 2 times 3. So what I wind up with are two groups of the exact same. Because of that, I can say that yes, 144 is a perfect square. Now let's just take that a step further. If I want to go ahead and find out what the square root is of 144, I can go a little bit further and just multiply out one of these groups. Okay, so I've got two groups, but if I just multiply one of them out, what I'm going to wind up with is the square root of 144. So 2 times 2 is 4, and then 4 times 3 is 12. And the way we write that is the square root of 144 is equal to 12. So here we go, square root 144 equals 12. As simple as that. Let me just prove one more thing. If I take all of these numbers, so 2, or not, 2 multiplied by 2 times 3 times 2 times 2 times 3 equals 144. And again, if I just multiply one of those groups out, 2 times 2 times 3, I wind up with 12, and that's the square root of 144. Pretty cool. Let's do some other examples here. All right, so let's try the number 1,000. So I know that I can divide 1,000 by 10, and there's 10 hundreds and 1,000. So 10 times 100 is 1,000. Then my 10's not a prime number. It can be broken down into a 5 and a 2. And 100 can be broken down into 10 and 10. So 5 and 2 are both prime. I'm going to go ahead and circle those right now. But my 10s can be broken down to another 5 and another 2 and another 5 and another 2. Again, those are all prime numbers, so I'll circle those as well. So what we have here are all the prime factors of 1,000. And the real question here to decide if 1,000 is a perfect square or not is can I fit those into two groups that are the exact same? So let's go ahead and try that. I'm just going to drag these numbers down. So if I move a 5 here and a 2 here, and then let's see, I'll drag another 5 down here, and then I'll drag a 2 into this one, and a 5 into this one, and a 2 into this one. Now, at first glance, those might look like two equal groups, but they're actually not, because 5 times 2 is 10, times 5 is 50, and 2 times 5 is 10, times 2 is 20. So 50 isn't the same as 20. Those groups are not the same. And it doesn't matter how I rearrange those numbers, there's no way I'm ever going to be able to put them into groups that are the exact same. And the reason is I've got not enough 5s and 2s to spread out evenly. Okay? So basically what we can say is that 1,000 is not a perfect square. Now I'm just going to switch over to pen and paper here, and we're going to do one more example, or maybe two more examples. So let's do this. Document camera fired up, and you'll be able to see a couple of more examples. And we're going to try the number 441, see if that's a perfect square. So 441 I can write down. I know because of the 9 divisibility rule that anything that adds up to 9, so 4 plus 4 plus 1 equals 9, is divisible by 9. So I'll just say 9 there, and then I'll grab my trusty calculator, and I will figure out what the other factor is that goes with that. So 441 divided by 9, that's equal to 49. So 49 goes here. Now, neither of those are prime numbers, so I can keep breaking them down. 9 breaks into 3 and 3. 49 breaks down into 7 and 7. So those are all prime numbers. I'm going to circle them. And this one's easy because I can just take 441 and make it equal to a 3 times a 7. That's my first group. And a 3 times a 7 in my second group. So because those two groups are the exact same and I've used all 4 of my prime factors, I can say that yes, 441 is a perfect square. Okay, we'll try another one here. Let's go ahead and try the number 75. So I think off the top of our heads, if we've got all the perfect squares memorized from 1 to 100, we know 75 is not a perfect square, but let's just prove it. So anything that ends in a 5, I can divide by 5. 75 divided by 5 is equal to 15. So I'll say 15 here. My 5 is a prime number. 15 breaks down into a 3 and a 5. And the question then becomes, can I put those prime factors into two groups that are the exact same? So I can try and take my 5 and put it here, times, well, I can put a 3 here. But then, the only number I have left over is a 5 here. So if I put the 5 into here, 5 times 3 is not equal to 5. So 75 is not a perfect square. And maybe we'll try one more. Let's try the number 10,000. So we did 1,000 before. We found that that was not a perfect square. Let's try 10,000 and maybe make some predictions based on what our first finding was, and maybe we'll be right, maybe we'll be wrong. So I'm going to start by breaking this down into 10 1,000s, and then 10 breaks down into 2 and 5. 1,000 breaks down into 10 and 100. 10 breaks down into 2 and 5. 100 breaks down into 10 and 10. 2 and 5, 2 and 5. So I'm going to circle all of my prime factors, and what I've got here is the opportunity to put these into two equal groups. So let's try and do that. I'm going to use this 2, I'm going to use this 5. I'm going to use this 2 and I'm going to use this 5. Then I'm going to use this 2, this 5, this 2, this 5. And you can see there that because I've got two groups of the exact same, that I've got a perfect square. So you can come back up and say, yes, 10,000 is a perfect square. Now, if I wanted to go a step further and find out what the square root is of 10,000, I would just multiply out one of my groups. So 2 times 5 is 10, 10 times 2 is 20, 25 times 5 is 100. So I know that the square root of 10,000 equals 100. Pretty simple to find the square root of a huge number like that. A lot of people are afraid of those big numbers, but in this case, it wasn't so bad. Let's just do one more example. I'm going to do the number 729. Now, I know from experience that 729 is divisible by 9. You may not know that. You might just have to start checking with some numbers. So you can see in my calculator, I get the whole number 81. So I know that that's divisible by 9. That's great. So I'm going to say 9 times 81. And then the 9 breaks down into a 3 and a 3. 81 breaks down into 9, 9. Each of those 9s breaks down into a 3 and a 3. So what I've got here are 6 3s. I can put those into two groups that are equal. 3 times 3 times 3. 1, 2, 3. And 3 times 3 times 3. So, yes, 729 is a perfect square. Let's go ahead and find the square root of that. I multiply out one of my groups. So 3 times 3 is 9. 9 times 3 is 27. If you want to check these in your calculator, you can always do that. Just take the square root of the original number, and you can see that. Calculator says 27, my paper says 27. We're good to go.